Hello guys, in this video I'm going to talk you through how to find the gradient of a line. So before we start, make sure when you're thinking about gradients of lines, you're always thinking from left to right, just like when you read a book, okay? You read the words going from the left to the right side of the page. So that means if we have a line that looks like this, if we look left to right, it's going upwards, so we say it has a positive gradient. And if we look at a line like this, going from left to right, it's going down, so it has a negative gradient. Now, there are various different methods for finding gradient, and if you search this online, you will find some formulas and things which are absolutely fine if they work for you. I'm going to start by talking through another method that I find I like because it's quite intuitive for a lot of people, but I will also be going through the other method as well. So by the end of the video, you will be able to choose which method works best for you. So the first method I'm going to go through with you today relies on ratio. And the reason I like this method is because it makes sense to people, because most people are quite confident with dealing with ratio. So I'm going to go through my ratio method first of all. So to begin with, let's say I had a straight line going from this point to this one, and I worked out the journey going horizontally across and then vertically to meet the line. I could describe that journey as 15 across and 45 up. And that's what I've written here. Okay, just make sure when you go across, you're always going left to right, as I said a minute ago. Now, the really cool thing about this is it works like a ratio. So what I can do is I can find any number that divides both of these, and I can divide down. So for example, both of these divide by 5, so I can make it 3 across 9 up. And still, both of these divide by 3, so I can make it 1 across 3 up. Or I could have noticed that both of these were in the 15 times table and divided by 15 straight away to get down here. Okay. You can also go the other way. You can go up. So for example, I could double both of them and get 2 across 6 up. Or from there, I could triple them and get 6 across 18 up. You can even go down into decimals. So from here, I could decide to half, and I could get 0.5 across, 1.5 up. Okay, so any of those relationships will actually end up, if you drew any of these and join them up, you would always end up with a straight line that had exactly the same steepness as our original line that we started with. So all of these are going to have exactly the same steepness or gradient. I'm going to try and show you that on a grid now. Okay, so what I'm now going to do is I'm going to show you how all of these different journeys which share this ratio that we had from the beginning are going to create the same steepness of line. I'm going to use this one to start my drawing off, because the 15 across 45 up one is going to be hard for you to see. I'd need squares that are too small. So I'm going to do 3 across 9 up. So I'm going to start down here somewhere. I'm going to go 1, 2, 3 across, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to pop my other point there. So we could describe this line going from A to B as 3 across 9 up. And you can see it's quite a steep line going upwards. So now let's think about the 1 across 3 up. If I started at A, and instead of going 3 across 9 up, I went 1 across 3 up, where would I end up? So starting at A, I'm going to go 1 across 3 up, and you'll see I end up at point D, which is still on that line. So 1 across 3 up has the same steepness as 3 across 9 up. What about if I went 2 across 6 up instead? So again, I'm going to start at A, and I'm going to go 2 across, and then 1, 2, 3, sorry, put the point there. 1, 2, 3, 4, 5, 6, and I will still end up, okay, on that line. Point F there is where I end up if I go 2 across 6 up. Okay, so we've also got the 3 across 9 up. Now you could, if you had square paper of your own, test 6 across 18 up, or you could test something like 4 across 12 up. Any numbers that work in this ratio will work. And I said before as well, didn't I, that you could go 0.5 across, 1.5 up, and that would also still work. So let's see that one working too. I'm going to start from anywhere else on the line I want. So let's say I'm going to start from F this time. If I go half across and then 1.5 up, I will end up still on the line. So any journey that follows this ratio on this line will always end up on the line again. Okay, so for gradients, if you set this ratio between the journey from left to right and the journey vertically, you are guaranteed to have exactly the same steepness. Now, when we talk about gradient, we need to choose which one of these we're going to use. And the one that we always use is this nice one here, where we have it always as one across. Okay, so if you've got it as one across, that's the one you need to look at for gradient. So for all of these different descriptions, we would say that the gradient is 3. So when you get it to the one across value, this is the number you use. Hopefully, when you look at the other ones, 3 seems like a really good idea anyway, because if you look at the 15 and the 45, if you multiply by 3, you get from one to the other. And again, for 3 and 9, if you multiply by 3, you get one from one to the other, and from 2 to 6, and 6 to 18, and all of those other ones. Okay, so we get the across value to 1, and then the other number tells us our gradient. Okay, so now we've gone through how that works, I'm going to show you how to use this method to find the gradient of a line. So let's have a look at these 2 examples before I give you a couple to do on your own. So first of all, let's say I had a line that went 7 across, 28 up. Job number 1 is let's make the across value 1, work out what this has to be, and that's my gradient. So to go from 7 down to 1, I need to divide by 7. I need to do the same over here as well. 28 divided by 7 is 4, so I need to pop my 4 in that gap, and therefore the gradient is 4. Let's have a look at another one as well. Let's say I had 8 across, 4 up. I need to make this value 1, so I need to divide by 8. Over here, I need to do 4 divided by 8. Now, 4 divided by 8 is not going to come out as a whole number. It's going to come out as less than 1. Any division can be written as a fraction. So I'm going to write 4 divided by 8 as 4 over 8, okay, which you can always do, and you will often have to with harder gradient questions. So the gradient of this line is 4/8, but we can simplify that fraction down to 1 over 2, or half. So the gradient of this line will be a half. Okay, so now we've seen 2 examples of me doing that. Pause the video and have a go at these 3 questions before playing to see me explain how to do it. Okay, so here is how I would think about the first one. I'm going 2 across, 10 up. I need to divide by 2 to get that to a 1 across. So when I divide the other side by 2, I'm going 5 up. So the gradient is 5. For the next one, I need to divide both sides by 9 to make it 1 across, 6 up. So the gradient is 6 for this one. Last one's a little bit more tricky. Well done if you manage this one. I need to divide both sides by 4, so it's going to be 1 across, and I'm going to write it as 10 over 4, or 10 quarters up. So my gradient is 10 quarters, sorry. Let's hold it up here. So my gradient is 10 quarters, which I can simplify down to 5 over 2, and 5 halves is the same as 2.5, or 2.5. Any of those is correct, but we would normally try and simplify it as much as we could. Okay, so I'm now going to have a look at these 3 lines which we've got drawn on a grid, and I'm going to work out the gradient of them from scratch. If after I've done one of these you feel able to do the other 2 on your own, pause the video and have a go before watching for the full explanation. So first of all, we're looking at the journey from A to B. Okay, so what I'm going to do is I'm going to start by drawing the journey from A to B. So from A, I'm going to go 1, 2, 3 across, and then 1, 2, 3, 4, 5, 6 up. You don't have to draw it if you don't want to. Some people can just see them visually, but if you want to draw it, we've got 3 squares across, 6 squares up. So if I write that down, 3 across, 6 up, I know I need to make it 1 across. I'm dividing this one by 3, so I've got to divide this one by 3, so it's 2 up. So therefore the gradient for my first one has to be 2. Okay, now let's have a look at the journey across and up for C to D. So to go from C to D, I've got to go 1, 2 across, 1, 2, 3, 4, 5, 6, 7, 8 up. I have to divide that down to make it a 1, So I have to half it to get it to 1 across, and then I need to half this one as well to make it 4 up. So my gradient is 4 for that one. Last one, this one's a little bit more tricky. I have to go 1, 2, 3 across, 1, 2, 3, 4 up. I need to divide by 3 to make it 1 across. Now doing 4 divided by 3, I'm just going to write as a fraction, 4 over 3, or 4/3. So my gradient is 4/3, which is the same as 1 and 1/3, or 1.3 recurring. If you are going to write thirds as decimals, that's fine, as long as you remember to put the recurring dot as well. Okay, so 1 1/3 or 4/3 for my final one. You'll notice this line with a gradient of 2 is less steep than this one with a gradient of 4, but more steep than this one with a gradient of 1 1/3. Okay, so here's the other way of thinking about gradient, which is actually doing exactly the same thing underneath, so it's just up to you which one you find easiest to think about. So you might have heard of gradient as rise over run, or as change in y over change in x, and you might not have seen this yet, but you will see it later on. If we have two coordinates, we can calculate it as y2 minus y1 over x2 minus x1. All of these three fractions are actually doing the same thing underneath. Okay, now looking at this example that we had earlier where we were going 15 across 45 up, we would say that the rise or the change in x is 45 and the run or the change in x is 15. So to find the gradient, we can just do 45 divided by 15, which is actually what we had to do when we had our 15 across 45 up. Okay, 45 divided by 15 is 3, so our gradient is 3. This method is nice and quick and easy as long as you remember which way round they go. Some people make little mistakes with this later on when they get the positive and negative the wrong way round. So this method is absolutely fine if you prefer it. It is doing the same thing as thinking the number across, the number up, and then dividing down to make the across value 1.